Good afternoon all. In today's class, we will discuss yield method, join method, sleep method, and one more method, that is interrupt. Okay, we will complete all these four methods. These four methods are very, very important for exam point of view also. So here the methods to prevent a thread from execution. So these three methods are used to prevent a thread from execution. So they are yield, join, and sleep. We will see one by one. First method is yield method. So yield method causes to pause the currently executing thread for giving the chance to the remaining waiting threads of the same priority. Okay, so yield method causes to pause the currently executing thread. Understand the meaning of this one. If you understand the meaning, program is very, very easy. Yield method causes to pause the currently executing thread. Okay, to pause the currently executing thread for giving the chance to the remaining waiting threads of the same priority. Okay, next, if there are no waiting threads in the waiting queue or all the waiting threads have the low priority, then the same thread will continue its execution. Okay. Next, the thread which is yielded, okay, then when it will get the chance once again for execution, it depends on the mercy of the thread scheduler. Okay, next, again, which waiting thread will get the chance also, we can't expect exactly, it depends on the thread scheduler. Okay, so yield method, this one is purpose is yield method causes to pause the currently executing thread. Okay, it causes to pause the currently executing thread for giving the chance to the remaining waiting threads of the same priority. So understand this one. After that, you can read these statements. Next, I will explain the program. Okay, with this yield method. So what is the syntax of all these methods are there in the thread class? Okay, so yield method is there in the thread class and it is a static method. So how do we access the static method of the thread class? Inside our class, that is outside the thread class. You know, class name dot method name. You know, static methods of one class can be accessed outside that class using class name dot method name, because yield method is declared as static. That's why how to access the yield method of the thread class is using class name dot method name. That's why whenever you want to access the yield method of the thread class, always write thread dot yield in your program, because yield method is declared as static. That's why accessing the yield method of the thread class is thread dot yield. Now last class I already explained this. Okay, you know this life cycle of thread, no? With the 4 state I already explained. So this 1, 2, 3 and 4. New or born state, ready or runnable state, running state, dead state. So this path I already explained. Now I will extend this life cycle of the thread by using this one more arrow. So this arrow is from running state to ready state. Means this arrow is from this state to this state. What is the meaning of this is, from the running state, the currently executing thread is going to this ready state, which is nothing but waiting state, by using the method thread dot yield. So by using the method thread dot yield, the currently executing thread, okay, so they take some time and it will go to this ready or runnable state. So what does it mean? Already explained. Yield method causes to pause the currently executing thread. To pause. Pause means, what is the meaning of pause means? From this running state, it will go to the ready state. That is nothing but thread dot yield method. So what is the role of thread dot yield method is, it is, okay, it is, what is the purpose is, it is giving chance to the remaining waiting threads of the same priority. That's why this currently executing thread is going to this waiting queue. Using which method? Thread dot yield method. So this is one more arrow we have to take from running state to ready state using this method, that is thread dot yield. So already you know the life cycle with 4 states. For that only I am adding one more arrow, that is from this state to this state using thread dot yield. Now we will see explain the yield method in multi-threading means first to explain theoretically. After that draw the diagram. This diagram is for thread dot yield method. After that, after drawing the diagram, okay, so take one program and explain thread dot yield. Here see, if you see, only this one statement I have added. So the program is same already. I have discussed the first program. No? First program is nothing but which extends thread. So I am taking the same program. Only I have added inside the for loop one statement, that is thread dot yield. Now we will see what is the purpose of this one and what is the flow of execution. So this is the only one statement I have added for the first program, that is class myThread extends thread. Okay. Now we will see. So here we are creating one thread, that is child thread, using class myThread extends thread. Inside that always we should write overriding run method. Inside that I am writing the functionality of that thread using this for loop. So inside the for loop I have written thread dot yield. This is the only one statement I have added in the for loop. Okay. Now this is the child thread. After that create main thread by taking one more class, that is class thread yield demo, public static void main. Now here this part also same as the first program, and this is also same as the first program. So only for the first program I have added inside the for loop this statement. Now I will explain the flow and what is the output of this program. So here inside the child thread, I have written thread dot yield, means child method. This child thread, okay, causes to pass the currently, means yield method. This yield method causes the currently executing thread, that is nothing but child thread, for giving the chance to the remaining waiting threads of the same priority. So here in the ready queue or in the waiting queue, we have 2 threads. Assume like this. What are the 2 threads in this program? This is the child thread and this is the main thread. So in the waiting queue, or with respect to this diagram also we can explain. So in the ready state or in the waiting queue, we have 2 threads. They are main thread and child thread. So inside the child thread, I have written thread dot yield. What does it mean? Suppose if the child thread got CPU, then it will go to the running state, no? But after that, here we have written what? Thread dot yield inside the child thread. That's why immediately from the running state, it will go to the ready state using thread dot yield. Means child thread is going from running state to ready state with this thread dot yield method. Then what will happen? Again in this waiting queue, okay, we have 2 threads now. That is main thread and child thread. So child thread is okay going from running state to ready state for giving chance to the main thread. Now my main thread will get the CPU and main thread will enter into the running state. Still this child thread is in the waiting queue only. That's why which thread is executed first? Because whenever child thread is going to the running state, because of this thread dot yield method, it is going from running state to ready state now. That's why child thread will not get executed. Okay, whenever it goes from running state to ready state, the main method is, or main thread is getting the CPU, means main thread goes to the running state. So what does it mean? What does it mean? So main thread completes its execution first, then child thread, because of this thread dot yield, which is there in which thread? Child thread. And that's why. So here which method is executed first or which thread is executed first? In the above program, the chance of completing main thread first is high, because child thread always calling yield method. Whenever child thread got the CPU, so whenever the run method is getting executed inside the child thread, so always it is invoking this yield method, that is thread.yield. So whenever it is invoking yield method, from running state it will go to the ready state. Means in the waiting queue, it will go to the waiting queue. At that time, this main method will go to the running state. Means main method will complete its execution first, followed by child thread will complete its execution. This is nothing but thread.yield. Okay, what is the purpose of yield method? It causes to pause the currently executing thread for giving chance to the waiting threads of the same priority. Okay, that is the yield method. So here, please execute in the lab, then you can understand more clearly. So with this yield method is completed. Only here I have written thread.yield method in the child thread. That's why the advantage is here. Okay, first main thread will complete its execution using this for loop, followed by child thread will complete its execution. So here you may get one doubt. Why we should write thread.yield method in the child class only? It is not compulsory. Here we have two threads, that is child thread and this is the main thread. No, here also in the main thread also we can write. So if you want to write thread.yield method in the main thread, inside the for loop write here thread.yield. So instead of writing the thread.yield statement in the child thread, we can write thread.yield statement in the main thread functionality. This is the functionality of the main thread. So if you write thread.yield here inside the main thread functionality, then what will happen? First child thread will complete its execution, followed by main thread completes its execution. Because whenever main thread got the CPU, always from running state it will go to the ready state because of this thread.yield method. So we can write yield method, okay, yield method of the thread class in any thread. Okay, not only in the main thread or not only in child thread. We can write multi-threaded programs with 6 or 7 threads. No? So in any thread, we can write the thread.yield statement. Okay. Now next second is join. So if you take the first program, yield method requires only one thread. No, here inside already explained. Inside the child thread, we can write yield method, or inside the main thread also we can write the yield method. Means yield method requires only one thread. We can write in any thread, whether it is main thread or child thread. But okay, that means what does it mean? Okay, to use the yield method of the thread class, one thread is enough. But if you take join method, it requires 2 threads. So with the 2 threads only, I can explain join method. But yield method can be explained with only one thread. Because inside only one thread, I am writing thread.yield statement. But join method requires 2 threads. Let us take T1 and T2. Okay. Now see the join method. If a thread wants to wait until some other thread completion, if a thread wants to wait until some other thread completion, then we should go for join method. So here I will explain more clearly. If a thread T1 executes T2.join, so here how many threads are there? 2 threads. So inside the thread T1, I am writing T2.join. What does it mean? First T2 completes its execution. Okay. After the completion of the thread T2 only, T1 completes its execution. Okay, till the completion of the second thread T2, T1 will wait in the waiting state. So here 2 threads must be required to explain the join method concept. So inside one thread, I will write T2 dot join. What does it mean? What does it mean? The thread T1 will go to the waiting state until the thread T2 completion. That is the meaning of join. If a thread T1 executes T2 dot join, then thread T1 will be entered into the waiting state until thread T2 completion. So with respect to diagram, I will explain. Again, in thread class, we have a method join, but this join method is called overloaded method in the thread class. See, same join, but they are differing the number of parameters. Means join method is called overloaded method in the thread class. And join method is also final method. Means final methods cannot be overridden in the subclasses. And one more is join method throws interrupted exception. Okay, for some methods they have declared like this, throws interrupted exception. You know, interrupted exception is a checked exception. I will explain this more clearly in the program. First, now remember the syntax of join method. So join method is said to be overloaded method in the thread class because it is having three forms. So here write open brace, closing brace, because it is a method now. Write the definition also, we can write. Okay. Now here, this is join with no parameters, join with only one parameter, that is milliseconds. Next, join with two parameters. First is millisecond, second is nanoseconds. Now with respect to two threads, we will see the join method. When you see the life cycle diagram, here this part is extra part which is added for the join method. Same diagram, these four states are same. Now I am adding this part. What is this part? I am taking one more state, that is waiting state. Okay. So whenever let us consider like this. Let us take two threads, T1 and T2, and T1 is in the running state. So when T1 is in the running state, inside T1 we have written T2 dot join. Then what will happen? Inside T1, when you write T2 dot join, so when if T1 is in the running state, then what it will do is T1 will enter into the waiting state to give a chance to T2 for execution. Now T2 will get the CPU and T2 will go to the running state and T1 is in the waiting state. Inside T1, if you write T2 dot join, what does it mean is, suppose if T1 gets the CPU, then inside T1 we have written T2 dot join. No? That's why if T1 gets the CPU, immediately T1 from the running state, T1 will go to the waiting state and the CPU is given to T2. Now T2 is in the running state because we have written T2 dot join inside T1. That's why first, until the completion of the thread T2, T1 will be in the waiting state. That's why how do I explain this one is, now T1 is, okay, T1 from the running state, T1 will go to the waiting state and T2 will enter into the running state. Next, here you may get one doubt. Here T1 is going to this waiting state now. From this waiting state, when it will go to the ready state, means it is here, it is waiting queue. So from the waiting state, when T1 will go to the waiting queue or ready state. Once it goes to the waiting or ready state, then only it will go to this running state. Directly from waiting state to running state, it can't go. So once the T1 will go from running state to waiting state, again the thread T1 has to go to this ready state, then only it can go to the running state. Now here the question is, so from waiting state to ready state, when the thread T1 will go. So what is the answer for this is, these are the points. So here inside T1, we can write either T2 dot join or T2 dot join of these many milliseconds or T2 dot join of the milliseconds and nanoseconds. Here it is time. Okay. So now our question is, okay. So T1 from running state, T2 goes to this waiting state. So from waiting state to ready state, when the T1 will go is if T2 completes its execution, because T2 got the CPU, now T2 is in the running state, so if T2 completes its execution, then our T1 will go from the waiting state to ready state. That is one concept. Or if time expires, here we have written time, no? If time expires, or if waiting thread got interrupted. Sometimes the here T1 is in the waiting state, no? If this thread got interrupted using one more method, that is interrupt method. In that case also, T1 will go from waiting state to ready state. T2 is in the running state, T1 is in the waiting state. When you write T2 dot join in the thread T1. Okay, now I will explain with the program also. Now to understand the join method clearly, this is important. So here I have 3 threads. When you fixing, printing wedding cards and distributing wedding cards. So here this is thread T2. So inside the thread T2, I will write T1 dot join. What does it mean? So T2 should wait, or T2 will go to the waiting state until the completion of T1. So in real time situations, what will happen? First we have to fix the venue, then only we have to print the wedding cards. No? That's why this should be done first. No? That's why T2 will wait. Means printing wedding cards. We can't do without venue fixing. No? That's why the thread T2 has to wait until T1's completion. So T1 dot inside T2, if you write T1 dot join, the thread T2 will wait until the thread T1 completion. Means first when you fixing, then only printing the wedding cards. So in real time we can say like this. So inside the thread T2, if you write T1 dot join, this printing wedding cards we have to wait until this venue fixing is completed. Like that we can explain. Next, take one more thread T3. So with respect to T2 and T3, I will explain. Inside the thread T3, if you write T2 dot join, then what does it mean? So what is the thread T3? Distributing wedding cards. Okay, so thread T3 has to wait until the completion of T2. Means first we have to print the wedding cards, then only distributing the wedding cards. No? That's why T3 has to wait until the completion of T2. Like that inside T3, we can write T2 dot join. Inside T2, if you write T1 dot join, this thread will go to the waiting state until the completion of this thread. Similarly, when you write T2 dot join inside T3, then T3 will go to the waiting state until the completion of the thread T2. So with respect to these concepts, you can understand more clearly when we use join method. If some thread wants to wait until the completion of another thread, okay, then inside the waiting thread, we should write the completion thread. Means inside T3, if you write T2 dot join, the thread T3 has to wait. Means it will enter into the waiting state until the completion of this thread T2. This is the real-time example to understand the join method. And now I will write one program on join method. Same, I am creating one thread, that is class my thread extends thread. This is the overriding run method. Inside I am taking for loop system.out.println Seta thread. This is the functionality of this child thread. Okay, now don't consider this try catch, leave it. Now we have a for loop. Inside the for loop, I have written only one statement, that is Seta thread. This is the functionality of the child thread, which must be written inside the overriding run method. Okay, so this is the child thread. Okay, now next we will go to the main thread. So thread join demo. Inside this main throws interrupted exception. Why I will explain here. Now my thread t is equal to new my thread. This is the child class object. Next t dot start. So here after t dot start, you know, two threads are there. Okay, in the waiting queue. Next, what I have written, t dot join, and understand carefully. This is the important statement here. Except this statement remaining is same as the previous one and first program only. So when you write inside the main thread, I am writing t dot join. So here how many threads are there? Main is one thread and this is child thread. Here this is main thread, this is child thread. So inside the main thread, I am writing t dot join. Like correlate this one. Here in the example what I have shown, inside T2, if I write T1 dot join, what does it mean? The thread T2 has to wait until the completion of T1. Now in the same way, inside the main thread, I have written T dot join. T means child thread. So inside the main thread, if you write T dot join, what does it mean? Main thread has to wait until the completion of the child thread. That's it. That is nothing but join method. Inside one thread, if you write, or inside thread T1, if you write T2 dot join, thread T1 has to wait until the completion of T2. Understand that concept. So here in this program, inside the main thread, I have written T dot join. So what does it mean? The main thread has to wait until the completion of this child thread. T is called child thread. No? This is child thread. So the main thread has to wait until the completion of the child thread. If you write T dot join in the main thread. Okay. So here if you see the diagram, the main thread will go to the waiting state and it has to wait in the waiting state until the completion of the child thread. Once the child thread completes its execution, at that time only the main thread will go from waiting state to ready state. Okay, that's it. So see the diagram and understand. Here the only important point is this one. I am taking the first program. I am modifying the program by adding only this statement. So try to understand the statement with two threads. Join method requires two threads. With one thread you can't explain. Here my two threads are main thread and child thread. Inside the main thread, if you write t dot join, main thread has to wait until the completion of child thread. Now here, this is the functionality of child thread. This is the functionality of the main thread. And this is the functionality of the child thread. Okay, this for loop is the functionality of the child thread. And this for loop is the functionality of the child thread. Now here, what will be the output? That is the question. Here again, I am repeating the same statement. Inside the main thread, I have written t dot join. The meaning of this is main thread will go to the waiting state until the completion of this child thread. Means which thread is completed first? This child thread. Okay, that's why child thread will complete its execution first, then only main thread will complete its execution. So if you see the output for this, see child thread functionality is inside the for loop we are writing, we have written Seta thread now. So that for loop is repeated 10 times, means child thread completes its execution. Then again, this main thread completes its execution. Okay. So with respect to this main thread and child thread, I have explained the join method. So when you write inside the main thread, okay, if you write t dot join, what will happen? Suppose let us assume that main thread got the CPU, means main thread is in the running state. But inside the main thread, I have written t dot join. So inside the main thread, if you write t dot join, okay, what is the meaning of that is immediately whenever that statement is getting executed inside the main method, that is t dot join, immediately this main thread will go to the waiting state. Now main thread is in the waiting state. Okay, here we have only 2 threads now. So when the main thread goes to the waiting state from running state to this state, then what will happen is in the queue, one more thread is there, that is child thread. Then the thread scheduler allocates the CPU to the child thread. Now understand, in the running state we have child thread, in the waiting state we have main thread. So which thread is completed its execution first is child thread, because it got the CPU and main thread is in the waiting state. So when the main thread will go from waiting state to ready state is once the child thread completes its execution. That's why when the child thread completes its execution means the output is Seta thread 10 times. Okay, so whenever it completes child thread its execution, at that time the main thread will enter into the ready state. Now in the queue only main thread is there, because child thread completed its execution. So in the queue only we have only child thread. Now the main thread in the waiting queue, not in the waiting queue, in the ready state or in the waiting queue, we have only one thread, that is main thread, because main thread is coming from this waiting state to this ready state. Now in this waiting queue we have only one thread, that is main thread. Child thread already completes its execution. Now because there is only one thread in the waiting queue, the thread scheduler allocates the CPU to the main thread. That's why now the main thread got the CPU and it completes its execution. So in this case, which thread completes its execution is first child thread followed by the main thread as per this diagram. Okay, that's why the output for this program is Seta thread 10 times, that is the child thread completes its execution first. After that only main thread got the CPU and it completes its execution. This is the functionality of child thread. This is the functionality of main thread. So this is the best program to explain. This is the best program to explain join method. Okay. This is the best method to explain join method. So next, till now I have explained two methods. They are join method and yield method. Okay. So what are the next two methods? Sleep method and interrupt method. Now I will explain sleep method. So sleep method is very, very easy. The third method is sleep method. So in the exam, if the question is explain the sleep method in multi-threading. So compared to the yield method and join method, sleep method is very, very easy. So this is the syntax of sleep method. Okay. So the sleep method is there in the thread class and it is an overloaded method because it has two forms. This is sleep with one parameter. Here it is sleep with two parameters. And sleep method throws interrupted exception. Okay. And it is a static method. So how do we access the sleep method of the thread class? Is thread dot sleep, because sleep method is a static method. Okay. Now the diagram for the sleep method is, so these four states are same. Next here from running state to ready state, in between there is one more state, that is sleeping state. In the previous diagram, in between running state and ready state, it is waiting state, no? If it is join method, but here if it is sleep method, from running method, first it will go to the sleep, from running state, first it will go to the sleeping state, again from sleeping state it will go to the ready state. So in between running state and ready state we have sleeping state in case of sleep method. So it is an overloaded method. It has two forms and these methods are there in the thread class and both are static methods. That's why we can access the sleep method of the thread class using thread.sleep. That's why here. Now I will explain what is the purpose of sleep method is. See here. If a thread doesn't want to perform any operation for a particular amount of time, if a thread doesn't want to perform any operation for a particular amount of time, then we should go for sleep method. Okay, like rest, it will take rest. So sleep is nothing but taking rest. So here, how to apply? So now let us assume that one thread is in the running state. But if that thread doesn't want to perform any operation for a particular amount of time, then at that time, if you are using sleep method from running state, that method will go to the sleeping state. Okay, from sleeping state, again it has to go to the ready state only. Again, always the path is from ready state to running state. Directly it can't go from sleeping state to running state. So when you suppose take one thread which is in the running state, if that thread doesn't want to perform any operation for a particular amount of time, at that time it will use sleep method to go to sleeping state from running state. At that time it will go to this sleeping state using thread dot sleep of long milliseconds or thread dot sleep of milliseconds comma nanoseconds. These two we can use. Next, so these many number of seconds it will be in the sleep state. Okay, once the time expires, that thread will go to ready state from sleeping state. Now here the question is, when the thread will go to ready state from sleeping state is here. These are the 2 points. If time expires, means here we have mentioned time, no? Okay, if time expires or if sleeping thread got interrupted. So when the thread is in the sleeping state, if some other thread interrupts this thread using interrupt method, then in that case also the thread which is in the sleeping state will go to the ready state. Ready state means in the waiting queue. So these are the two possibilities to go to ready state from the sleeping state. Okay. Now I will explain one program. So here we have class test, public static void main string args throws interrupted exception. Here this is thread dot sleep. I have written thread dot sleep, thread dot sleep, thread dot sleep. So first it will, when here only one thread is enough. So one more important point to remember is, for sleep method one thread is enough. Okay, for join method 2 threads are required. For like that, here for sleep method one thread is enough. So here which thread? It is the main thread. Okay, main is the thread. So inside one thread I am writing system.out.println v. So after execution of this statement, means now it is in the running state, no? Our main thread is in the running state. So after execution of this statement, okay, the main thread wants to take some time rest. Using this statement, it will take rest. Means thread dot sleep of 3000. What does it mean is, from running state, that thread will go to the sleeping state and it will sleep for 3000 milliseconds. Okay, after completion of that time, again from sleeping state, it will go to the ready state. Next, after that, from the ready state, again it will go to the running state. When it goes to the running state, again it will print this one, system.out.println a. So after printing this or after execution of this statement, again I have written thread.sleep of 3000. Means again from running state, it will go to the sleeping state and it will sleep for 3000 milliseconds. So after completion of these 3000 milliseconds, again it will go to the ready state from sleeping state. Again it will get the CPU and it will execute this statement. Again it will sleep for 3000 milliseconds. Like that, in between, after printing V, it will go to sleeping state. Again after printing A, it will go to sleeping state. After printing S, it will go to the sleeping state. Means it will sleep for some time. Here the output is only VASU. But after printing V, it will go to the sleeping state and it sleeps for 1000 milliseconds. Like that, you will get V. Next, after some time, you will get A. Next, after some time, SU, like that. Here, the output will be VASU. So, this is the program on sleep method. Okay. So, the last method is interrupt method. This is the last method. So interrupting a thread. So a thread can interrupt another sleeping or waiting thread. Already explained in join method, we have waiting state, and in sleep method, we have sleeping state in the diagram. So a thread can interrupt another sleeping or waiting thread by using interrupt method of the thread class. If you see the previous diagrams, here this is sleeping state, here I have written C. If sleeping thread got interrupted, so when this sleeping thread got interrupted is if you write interrupt method, this statement. Next in the join method also, in the diagram I have written, there we have taken waiting state now. So this is join method. So this is waiting state now. When the thread is in the waiting state, here I have written if the waiting thread got interrupted, means when this waiting thread got interrupted is by using interrupt method. So in these two cases, in join method I have written the statement if waiting thread got interrupted using the interrupt method, or in the sleep method life cycle also I have written from the sleeping state when it will go to the ready or runnable state is if the sleeping thread got interrupted by using interrupt method. That's why interrupt method is very, very important. Okay. Now interrupting a thread. So a thread can interrupt. Here also we need two threads. So a thread can interrupt another sleeping or waiting thread. So this is one thread and this is another thread. So here two threads are required. So a thread can interrupt another sleeping or waiting thread by using interrupt method of the thread class. So interrupt method is available in the class thread. So what is the syntax of interrupt method is public void interrupt. It is not taking any parameters. So here how many threads are required for applying interrupt method of the thread class is 2. So here a thread can interrupt another sleeping or waiting thread by using sleep method throws interrupted exception. No? That's why here we have to write try catch blocks. So write inside the try block, write thread dot sleep of 2000, and inside the catch block, this is the matching catch block, that is interrupted exception. So here I have written I got interrupted. Next, this is the child thread code. You know how do we create a child thread is using extends thread. So class my thread extends thread inside the overriding method, overriding run method I have written thread dot sleep, and I have used try catch blocks because sleep method of the thread class throws interrupted exception. Okay, so after writing the code for child thread, take the main thread. So class interrupted demo, this is the main thread. So public static void main, this is the main thread. Next here, this is the, these two statements, no? So after that I am writing, whenever you execute this statement, that is t dot start, here two threads are there and two threads are registered with the thread scheduler after t dot start. Okay, that is main thread and child thread. Here I am writing inside the main thread, I am writing t dot interrupt. T dot interrupt. Okay, then next system dot out dot println end of main method. Next, what will be the output here? So here, if we are not commenting the line 1 means this is the one. So if you take this line as it is, that is t dot interrupt, then what will be the output is, this is the output. First lazy thread, then end of main, then I got interrupted. T dot interrupt means here after this statement lazy thread, first it will execute this for loop first time. No, that is first it will print lazy thread. After that thread dot sleep means this child thread enters into the sleeping state using this thread dot sleep. So when this child thread is in the sleeping state, okay, by using this T dot interrupt, so that thread is interrupted. Okay, so that's why what will be the output of this program? Lazy thread, then end of main, then I got interrupted. When that child thread is interrupted, so means here, okay, using this statement thread dot sleep of 2000, our thread is in the sleeping state. When that thread is in the sleeping state, that thread got interrupted by using T dot interrupt. So when the child thread is in the sleeping state, and when it got interrupted using T dot interrupt, what it will do is, what will happen? So it is like an error. You know errors, no? Runtime errors. Then from this is tryback, no? So from this statement, immediately it will go to the corresponding matching catch block. So inside the matching catch block, I have written I got interrupted. So because of this T dot interrupt with this statement, it will go to the catch block and it will execute the catch block and it will print I got interrupted. That's why the output will be lazy thread, end of main, and I got interrupted. Okay. Next, in the same way here, what I have written one more program using interrupted method. In the first program, I have written system.out.println and thread.sleep in the same for loop. No? This is the closing of for loop and this is the closing of try block. So inside the for loop, I have written system.out.println and thread.sleep. That's why you will get this output. No, this is the output for this program. In the same way, I have written one more program for interrupt method. That is same. This is the child thread. So here what I have taken is inside the for loop I have written lazy thread, system.out.println lazy thread. But thread.sleep I have written outside the for loop. See the difference between the previous program and this program, that is for interrupt method. In the previous program, I have written the thread.sleep statement inside the functionality of the child thread inside the for loop. Inside the for loop, I have written thread.sleep of 2000 in the previous program. But in this program, I have written thread.sleep of 2000 outside the for loop. Same program. Okay. So try to understand the difference between these two programs, that is for interrupt method. So in the first program, I have written thread.sleep, okay, inside the for loop. Means 10 times this for loop is repeated. Now here I have written thread.sleep outside the for loop. Then you can see the difference in the output. So for this program, the output will be, this is the output. So first end of main, next lazy thread, lazy thread, lazy thread. Because thread dot in the second program, thread dot sleep method is not there inside the for loop. That's why the for loop is completely executed 100 times. So after completely execution of this for loop only, we have thread dot sleep. So whenever you write thread dot sleep, the child thread will enter into the waiting state, not waiting, sleeping state. Thread dot sleep means the thread will go to the sleeping state. So from the running state, the thread will go to the sleeping state, and there it will sleep for some time, some 2000 milliseconds. Okay. After that, here we have written in the previous program we have written T dot interrupt. T dot interrupt means the sleeping thread, that is the child thread which is in the sleeping state, got interrupted using the statement T dot interrupt. So when it got interrupted, what will happen is, from that try block, it will go to the corresponding matching catch block. That is, catch block is executed and the output is I got interrupted. So these are the two programs I have taken to explain the interrupt method. So only difference between the first program and second program is, in the first program I have written thread dot sleep inside the for loop. That's why when for loop is executed first time, first it will print lazy thread. Only one time only the for loop is executed when I is equal to 0. Okay, when I is equal to 0, it will enter into the for loop in the first program, and it will print lazy thread. After that, immediately the next statement is thread dot sleep of 2000. No, immediately it will go to the waiting state, and it got interrupted. That's why the for loop is not executed in the first program. In the first program, the for loop is executed only once, that is when I is equal to 0, and it will print only lazy thread only one time. After printing lazy thread one time, that is for I is equal to 0, immediately the next statement inside the for loop is thread dot sleep. From that statement thread dot sleep, it will go to the sleeping state. After that, using T dot interrupt, this sleeping thread got interrupted. Means the remaining that for loop is not repeated. But in this second program, inside the for loop I have not written thread dot sleep. That's why first that for loop is executed 100 times, followed by I have written thread dot sleep. So at that time only the thread will enter into the sleeping state, and again from the sleeping state it will go to the ready state using T dot interrupt. That's why here catch block is executed. Okay. So this is the output for the second program. So try to complete all these programs. These 4 methods are very, very important for exam point of view. Don't by heart the programs. Try to understand the concept. So summary of yield, join and sleep methods. So yield method, join method and sleep method. Here I have written what are the differences between these 3 methods, that is yield, join and sleep. Okay. These 4 methods are very, very important. So all these methods are there in the thread class only. Okay. Now here yield method purpose I have written, join method purpose and sleep method purpose I have written. Next what is the next concept is it overloaded method. Already we have seen the syntaxes for all these 3 methods. You know yield method is not an overloaded method because it has only one form, whereas join method and sleep method are overloaded methods because there are 3 forms for join method and there are 2 forms for sleep method. Next, is it static? Okay. So join method, first method is yield method is a static method, and join method, yield method is a static method. Join method is not a static method. That's why we are writing T dot join with the reference variable only. We are invoking the join method. So inside the main thread I have written T dot join. That's why it is not a static method. With reference variable only we have to access the join method. But whereas yield method and sleep method are static methods, that's why with the class name only we will access these 2 methods, like thread dot yield. Here it is thread dot sleep, because yield method and join method, yield method and sleep method, these 2 methods are static methods. That's why using class names we can invoke these 2 methods. Next, is it final? You know, final methods cannot be overridden in the subclasses. If you take yield method, it is not a final method, and sleep method is also not a final method, whereas join method is a final method. Next, is it throws an interrupted exception. Here join method throws interrupted exception, sleep method also throws interrupted exception. Next, last one not necessary. So here try to understand the differences between yield method, join method and sleep method. So with this we have completed 4 very important methods in multi-threading. They are yield method, join method, sleep method and interrupt method. Okay. Next class, we will complete the remaining part of multi-threading, that is synchronization. Synchronization is also very important. Okay. Try to complete up to this one.